All right, so we have a kid throws a ball at a wall that is 20 meters away. If she throws the ball with an initial velocity of 15 meters per second at a 40-degree angle, how high up will the ball hit the wall? So the first thing we want to do here is we got to recognize that she's throwing at an angle. And so what I'm going to do is just draw a little arrow to represent the vector. That would be the 15 meters per second at which she is throwing it. We need to break that up or resolve it into its x and y components. So we draw the little rectangle or triangle to represent that, and the angle is going to be 40 degrees. This will be my opposite side. This will be my adjacent side. And since this is the velocity, the 15 meters per second, basically this right here will be the velocity in the y direction, and that's the initial velocity because gravity will be acting on it as soon as it leaves her hand. This right here will be the Vx, and we could just say Vx because that's not going to be changing since there is no net forces acting on it, either forward or backwards, no horizontal forces acting on it. So this is our triangle, and based on this we can say, well, our Vyi or Viy, doesn't matter the order there, it's the initial velocity in the y direction. Since it's the opposite side, we're going to use sine, so SOHCAHTOA. So what we're going to do is, we've been down this road many times before, we're going to take our hypotenuse, our 15 meters per second, multiply that times the sine of 40 degrees, and that will give us our y component of our vector, and that would be 9.64 when I put in my calculator, meters per second. Our Vx is going to be the adjacent side, and so we take our 15 meters per second, multiply that by the cosine of 40 degrees since it is the adjacent side, and that will give us a 11.49 meters per second. Meters per second. So we've just resolved our velocity, the velocity vector that she threw it at. Now we know a few other things. We know that the acceleration in the y direction is negative 9.8 meters per second squared. We know that she threw it 20 meters away, and so what that means is that is our dx. That is the distance, or displacement, I should say, the displacement in the x direction from where it began to where it ended was 20 meters. So what we really want to know is how high up will the ball hit the wall? And so that is our displacement in the y direction, and we don't know the answer to that one. Just like with so many of these problems, the first thing we want to do is find the time. And just like every other situation, we don't ever want to mix x's and y's. So in this case, we want to look for what has the most information with which we could find the time. And so it looks like we've got distance and we've got velocity in the x direction. Y, we're missing some information, so that's unlikely going to be what we're going to use to find time. So I'm going to start with my very first equation that we learned. Velocity is distance over time. And because we're dealing with the x's, I'm just going to put an x there to just remind me of that. What I want to do, though, is find time. So I'm going to rearrange this equation. I'm going to multiply both sides by t and then divide by v. So that will mean that time will be our displacement in the x direction divided by our velocity in the x direction. And our displacement in the x direction is 20 meters. And our velocity in the x direction is 11.49 meters per second. And so our meters are going to cancel out, leaving us with seconds on the bottom of the bottom. When that happens, that just means that it comes to the top, the numerator. And when we put that in the calculator, we get 1.74 seconds. And I like to put a little fluffy cloud around that because it is important, though it is not our final answer. So we're going to use that momentarily because now we have time. And just like all the other questions and problems in this situation, once you have time, you have unlocked the key to every other aspect that you're trying to find. In this case, we are trying to find dy. And dy is our question mark. And if you look on the equation sheet, probably the best equation we can use is d is equal to 1/2 at squared plus VI times time. And we've already got our Y. We're going to make sure we're using the Y's components only. We don't want to mix X's and Y's in an equation. And then we just plug in our numbers here. And so that is equal to 1/2 of the acceleration, which is negative 9.8 meters per second squared. We have to remember that negative. It is vital that we do, because it is going downward. And so we have to denote that with a negative. Time squared, so 1.74 seconds squared, plus our initial velocity in the y direction, which was 9.64. So we're just going to take that, and 9.64 meters per second times time again, 1.74 seconds. Now, when we squared this when we square the time in this first part of the equation, we only want to square time. We don't want to square the entire thing. Just get your order of operations correct, and you'll be fine here. So when we do this, we're going to find out, when we put it in our calculator to do it correctly, that it is going to hit the wall 1.9 meters up. And that is basically how you do it. So to recap, you list all your variables, making sure that you have the X's and Y's straight. Make sure you remember that AY is negative 9.8 meters per second squared. These are positive, even though in the Y direction. Why is it positive? Because it is going upward at an angle and to the right at an angle. So upward and to the right, we denote as positive. Downward, it's the acceleration of gravity, is a negative. Our displacement is a positive number as well, because it's going to the right. Okay, so that's where we get these negatives and positives from. Then we find the time, and then we use the time to solve for the variable that we want, which is dy.